Okay, so in this lecture we will talk about how changing feature changes the result analysis, and how you can change any feature of an existing model and make it valuable, and make it manufacturable. So let's get started. To do this test, we will draw a C bracket, and we will run structural analysis on this. So let's open up file, new. We will create a new part. Okay, so let's go to sketch, and let's change the dimension to millimeter. Okay, we will select right plane and we will click sketch to normal. All right, so let's take line here, draw a random line like this. Okay, click escape. Let's give some dimension to this line here. We will give it 50 millimeter. We will give this 45. This will be 35, and here this will be 35. And let's draw another line here from this point to this point, and let's give the dimension to this line here. We will give it 75. Let's make it 80 millimeter. Okay, so let's assign some angle here. We will give this dimension. Okay, let's keep this 135 degree. There it is also 135 degree. 135 degree. Okay, so the feature has been drawn. Now let's go to offset entities. We will offset this drawing right here. We will change the dimension to 3 millimeter. That will be the thickness. Let's select this line and we will click reverse. Okay, let's click OK. Now let's fill up this point. Okay, escape. Now let's fill up this point here also. Okay, so as you can see, the drawing has been completed. So we will now go to features and we will extrude this. We will extrude this up to 30 millimeter. Okay, as you can see, this is a C bracket. So we will first run on this a structure analysis without the fillet. Here you can see you can add fillet in these points right here. So at first we will run the analysis without any fillet in it. So let's go to simulation and create new study, and we will click here on static and we will name it without fillet. Let's click OK. Okay, so the study has been created. Now let's apply some material here. Okay, we will apply alloy steel. Let's click apply and then click cross. Okay, so the material has been applied. Now let's go to fixture advisor and click on fix geometry as previous method. We will want to fix this geometry right here and we will click OK. Okay, so now we want to apply some forces on this surface right here. If we apply some forces on this surface, then how will this C bracket will react? We will measure that analysis. So let's go to external load advisor and click on force. Okay, so let's select this surface right here, and let's give the dimension to 9000 Newton and click OK. Okay, so the surface has been selected, as you can see. So now we will create mesh. In previously we saw that how changing the mesh density changes the result. In this we will see how changing features change the result analysis of a certain model. So let's create mesh and drag it to fine area. This will be fine, and let's click OK. So here you can see the mesh has been created on this C bracket right here. Now what we will do, the next step will be run this study. Okay. As you can see here, it is showing some excessive displacement. We will just click OK. Maybe we have applied a much more load than the yield strength. That's why the notification was showing. We will change it. Let's just calculate it first. Okay, the study was not running because of the large displacement. We will go to this force right here, and we will click on edit definition. The force was much bigger. We will apply 1000 Newton, and then we will click OK. Then again let's run this study. As you can see, the study has been running now. So as you can see, the result has been shown. So here you can see The yield strength is 6.20 into 10 to the power 8, and the maximum stress is 1.29 into 10 to the power 9, which is pretty larger, even if we have reduced the force right here. So we need to change the force item right here. So let's right click on it, and let's again go to edit definition, and we will reduce it up to 500. Let's see what happens when we apply 500 Newton. So let's run this study again. So it will take some time. Here you can see it is running faster than the previous analysis, as the load is been lesser. It's solving now. This will be fine this time. So as you can see, the result has been calculated. So it's still, you can see the von Mises stress, the maximum amount of stress is higher than the yield strength. So this model is not valid yet. We have created the dimension in less amount. That's why the load is being always higher. So let's once again change the load right here, and let's give it only 200, and we will click OK, and we will run the study again. So this is what happens when the model is not able to take the load. So this is you can keep in mind that how excessive load can act on your simulation. So let's see what happens now. Okay. Okay. So as here you can see, when we have applied on the 200 Newton in this model, the maximum amount of stress is 2.90 into 10 to the power 8 Newton per meter square, while the yield strength is 6.20 into 10 to the power 8. So if we go to result right here and I click on it, and if we check the factor of safety, define factor of safety plot here, and if we click OK, here you can see the factor of safety for this design is 2.1, and the red area is showing where will the breakage will occur. So let's do some fatigue test right here. In the previous model we couldn't see the fatigue test So let's go to define fatigue check plot, and let's click OK. So we will apply the force right here, and we will keep this loading factor axial. We will keep this surface finish factor ground, and we will keep the size factor to 0.75. Let's keep this as it is, and let's click OK. So let's it is showing the fatigue test, fatigue plot, and fatigue image. So the from the stress analysis, we can see the maximum amount of force is stress is 2.90 into 10 to the power 8, and the distance is higher than the maximum stress. So the model will not break in this case. So we will see the displacement for now. Let's click on show, and as you can see, the maximum displacement will occur in this part right here. So this is the analysis without the fillet. Now we want to run this same analysis on some fillet in this point right here and in this point, with here and in all the edges. So to do this, let's go to features, and let's just first save it. We will save it without fillet, and let's click save. So the study has been saved. Let's click yes. Okay, we will again go to the sketch part, and we will go to 3D views. And now let's go to features, and let's add some fillet. Okay, we will add fillet in this point, in this edge. Let's keep the fillet dimension 5 mm, will be okay. We will add fillet in here. We will add fillet in this point and in this point also. And let's click OK. So as you can see, the fillet has been done. So now let's go to simulation, and let's create a new study here, and we will name it with fillet. Okay, let's click OK. So here you can see a new study has been created. This is the study for without fillet, and here it is for with fillet. So let's go to again to the feature, and we will add some fillet on this point also. Let's give it 5, and as you can see, let's add some fillet here also. Let's click OK. All right, so let's again go to simulation, and let's apply material. The material will be applied same as before. Okay, the material has been applied. Now let's go to fix advisor, fix geometry, fix this here, click OK. Load advisor, external load, and let's apply force. We'll apply force on this, and we will apply similar as before 200, and let's click OK. And let's create mesh here, and we will create the similar mesh as the previous one here, and we will click OK. As you can see, that mesh has been created. So now let's run this study. Okay, the material is not defined yet, so let's apply alloy steel. Let's click apply. run this study. So as you can see, the result has been calculated. So here you can see the maximum stress is 2.45 into 10 to the power 8, while the yield strength is 6.20. If we go to the first analysis, here you can see, if we click on show, here you can see the maximum, the yield strength is same for both the model, but the maximum stress has been lessened when we have created the fillet. Here you can see, let's show 2.452 into 10, 2.45 into 10 to the power 8, where it is in this model, that is 2.95 into 10 to the power 8. So creating a fillet has been lessen the maximum amount of stress for this model. So this is how a change in feature can affect your model. I hope this is clear to you guys. So let's here in this model we have, let's click show. Let's analyze the factor of safety. Here you can see the minimum factor of safety is 2.1. So if we go to the with fillet model, and let's right click on result and click on factor of safety plot, and let's click OK. Here you can see the factor of safety is 2.5, which is larger than the previous model. So I hope you have understood that how the change in the features, how we can increase the factor of safety for any model. And if we right click on here and check the fatigue check, define the fatigue check plot, and we click OK. Here you can see the fatigue has not changed much with the previous one. So let's click show. So here you can see. So this is how, and let's compare the displacement also. So let's right click here and click on show. Here you can see the maximum displacement is 4.35 into 10 to the power 4.35 millimeter for this model with fillet. And here if we go to without fillet and click on show the displacement, here you can see the displacement is 4.389, which is smaller than the fillet one. So this is how changes in features affect the structure analysis. So I hope I could make this clear to you guys, and thank you for today. I will catch you in the next one.